Before we look at the actual test question, here's a warm-up question. Which of these hydrogens, the one on top or the one on bottom, is more acidic? Here's a clue. The more stable the conjugate base, the stronger the acid. Here are the conjugate bases of the compound on top and the compound on bottom. We see that for the compound on top there are 4 resonance contributors, and for the compound on bottom there are none. Resonance helps to stabilize the conjugate base, and therefore the more stable conjugate base is the compound on top, and therefore this hydrogen on top is the more acidic one. Okay, you can pause the video if you'd like to view this longer. Let's take a look at the actual question. The actual question is, what is the most acidic proton? Now we can eliminate answer choice B because it contains an aromatic ring. The aromatic ring is very stable and therefore will not want to lose its stability by helping to stabilize the conjugate base. Now we'll have to explore the other compounds that we have here. And remember, if you're dealing with questions from the chapters involving aromaticity, quite frequently aromatic compounds are going to be part of the answer. That just makes sense. For example, like this critter right over here. Here we have an aromatic ion. And here's how you'd form that aromatic ion right over here. By removing a hydrogen and forming a carbanion, you get this aromatic structure, and you might notice in answer choice D that this structure over here is similar to this structure over here. Let's take a look at what would happen if we removed a hydrogen from right over here on compound D. We'll leave this up right over here and make some room right here to take a look at what we're going to get. And there it is. If we remove this hydrogen here from compound D, you'll see that we get 4 resonance contributors. Pause the vid if you'd like to view it longer. 1 of which is not aromatic, 3 of which are aromatic. So not just resonance, but aromaticity is important in stabilizing the conjugate base, and as a result, D has a fairly significant acidity on this proton that you see right over here. All right, well, we still need to take a look at these other critters. Let's take a look at answer choice A, and we'll be abstracting a proton adjacent to the pi system over here, and we're going to see what we're going to get. Now we see the resonance structures here. There's 4 contributing structures, but none of them are aromatic. As a result, we can safely say that this proton right over here is less acidic than the proton we just looked at in D. Now, as far as C goes, if you'd like to, you can go ahead and maybe pull this proton off, and what you'll find is, just like in A, you get 4 resonance contributors, but none of them are aromatic. Therefore, D is the answer because it has the most stable conjugate base.